Welcome to Topic 4, Unit 1, the Law of Sines. When we have an oblique triangle, which is when none of the angles is a right angle, we're not able to use the Pythagorean theorem and SOHCAHTOA to solve the triangle. In our investigation, we did study what happens when we have case 1, where one side and two angles are known, ASA or SAA, and we also saw what happens when two sides and the angle opposite one of them are known, SSA. For these cases, we're able to apply the law of sines. Recall from your investigation that the law of sines looks like this. The sine of A over A equals the sine of B over B equals the sine of C over C. Now, because these are ratios, you could also have A over sine of A equals B over sine of B equals C over sine of C, depending on what you're looking for. So let's go ahead and try example 1. Example 1, solve the triangle if angle A equals 40, B equals 60, and side A equals 4. You should always start by sketching the triangle. A, B, C, angle A is 40, angle B is 60, side A is equal to 4, and I'll just label the missing sides. So here I have a side angle, which means I can use the law of sines. So I am going to start by finding side B. B over sine of B, or sine of 60, is equal to A, 4, over sine of 40. This means that B is equal to 4 times the sine of 60 divided by the sine of 40, and if I put this into my calculator, I get that B is equal to 5.4. Now, in order for me to find side C, I need to find angle C. Because I know two angles in the triangle, I can say that angle C is equal to 180 degrees minus the measures of the two given angles, and angle C is equal to 80 degrees. Now that I know angle C, I can find side C by saying C over the sine of 80 is equal to 4 over the sine of 40, or C is equal to 4 times the sine of 80 over the sine of 40, and for C I get a measure of 6.1 units. Example 2. Solve the triangle if angle A is 35, B is 15, and side C is equal to 5. So we're going to start by drawing a triangle. A is 35, B is 15. Here's angle C. Here is side C, which equals 5, and I'll put my missing sides B and A. Here I have angle side angle, which is also cause for using the law of sines. Now, in order to use the law of sines, I have to have the measure of a side and the measure of the angle opposite, and I don't have that right now. So I'm going to need to calculate angle C first, but since I know the other two angles, I can say C is equal to 180 minus 35 minus 15, which is equal to 130 degrees. Now I can find either side. I'll start by finding side A, so A over the sine of 35 is equal to C, which is 5 over the sine of C, which is 130 degrees. So A is equal to 5 times the sine of 35 over the sine of 130, which is equal to about 3.7. And then I can find B the same way. B over the sine of 15 is equal to 5 over the sine of 130, which means B is equal to 5 times the sine of 15 over the sine of 130, which is equal to 1.7. When we see SSA, we call this the ambiguous case, and we have already explored this leading up to this video, and you should know that SSA triangles may lead to one triangle, two triangles, or no triangle. So we have to handle these a little bit differently when we solve them. So example 3, solve the triangle if A equals 3, B equals 2, and A equals 40. Like always, we start with a picture. So I'll put A equals 40, which means the side opposite is A equals 3. I'll say that this is B equals 2, which means this is angle B, this would have to be angle C, and this would be side C. So notice that I have a side angle, which means I've got to be alert to the ambiguous case. So I'm going to start by looking for angle B. It's the only thing I have enough information to find right now. So I'm going to say that the sine of B over 2 is equal to the sine of 40 over 3. This leads to the sine of B equaling 0.4285. If I evaluate the inverse sine of that number, I get that angle B is equal to 25.4 degrees. Now remember, since sine is positive in quadrants 1 and 2, there is another angle in quadrant 2 that has the sine of 0.4285. And remember, that angle is going to be supplementary with the angle we just calculated. So I'm going to call this B1, and I'm going to call my possible other angle B2. And I'll find it by subtracting 25.4 from 180, and I'm going to get 154.6 degrees for my B2 in my possible second triangle. Now, in order for me to have a second triangle, the sum of the angles in any triangle can only add up to 180. So I'm going to check for my second triangle by adding up the angle I found to my given angle of 40 degrees. Now this is equal to 194.6 degrees, which is greater than the total number of degrees that can be in a triangle. This means then that there is only one triangle. So I can ignore my angle B2 and continue solving. So if angle A and angle B are known, I can say that angle C is 180 minus 40 minus 25.4, and I get that angle C is 114.6. And then finally I can find side C by saying C over the sine of 114.6 is equal to 3 over the sine of 40 degrees, which gives me that C is equal to 4.2. Example 4. Solve the triangle if A equals 6, B equals 8, and A equals 35. Again, I will start by drawing a triangle. I'll say this is A, and that's 35. Its opposite side is 6. If B is equal to 8, then this has to be angle B, this is angle C, and this is side C. So I'll start by looking for angle B. So the sine of B over 8 is equal to the sine of 35 over 6. This leads me to the sine of B equaling 0.7648, which gives me an angle B equal to 49.9 degrees. I'll call this B1, and I'm going to look for a B2 that's in quadrant 2 that shares the same sign. So B2 would be equal to 180 minus 49.9, and my B2 is equal to 130.1 degrees. Okay, now we'll check for possible second triangle by adding my B2 to my starting angle of A of 35, and I get 165.1 degrees. Now that's less than 180 degrees. That means there is room for there to be a third angle, which means I have a second triangle or two triangles. So now I'm going to have to solve for both of them. So I know that my first triangle, B1, is 49.9. My second triangle, my B2, is 130.1 degrees. I'll find my angle C on my first triangle, and that's going to be 180 minus 49.9 minus 35, and that is equal to 95.1 degrees. In triangle 2, I'll find my C2 by taking 180 minus 130.1 minus 35, and I get my angle in triangle 2 to equal 14.9 degrees. And then finally, I'm going to find side C in triangle 1, so C1 over the sine of 95.1 is equal to 6 over the sine of 35, and that gives me a C1 equal to 10.4. In triangle 2, I have C2 over the sine of 14.9 is equal to 6 over the sine of 35, and C2 from my second triangle is 2.7. Example 5, solve the triangle if A equals 2, C equals 1, and C equals 50. So I'm going to draw my triangle. Here's C, that's equal to 50. Side C is equal to 1. Side A is equal to 2, which means I'll call this angle A and this angle B, and this is side B. The only thing I can look for right now is the measure of angle A, so I'm going to say sine of A over 2 is equal to sine of 50 over 1. So sine of A is going to be equal to 2 times the sine of 50, which is equal to 1.53. Now if you were to put that into your calculator to evaluate the inverse sine of 1.53, you're going to get an error. This is because 1.53 is outside of the range of sine. Remember that the range of sine has to fall between -1 and 1. There is no angle that has a sine that's equal to 1.53, therefore no triangle. Finally, we're going to talk about area of a triangle. If you look at the triangle drawn right here, we know that the formula for area of a triangle is 1/2 base times height. And if you look at this triangle, the base is equal to B, but if I had to find the height, I could use SOHCAHTOA. I could use this little right triangle here, and I could say that the sine of C is equal to the opposite H over the hypotenuse A, which means that H is equal to A times the sine of C. So now I could say my area of the triangle, we like to call that K, is equal to 1/2 times the base B times the height A times sine of C. This leads us to the three formulas that we see here. We just derived this one right here, K equals 1/2 AB sine of C, but this can also work if you're given different measures. Example 6. Find the area K of the triangle for which A equals 8, B equals 6, and C equals 30. So the area K is going to be 1/2 AB times the sine of C, or 1/2 8 times 6 times the sine of 30, and 1/2 times 8 times 6 is 24, and the sine of 30 is 1/2. 24 times 1/2 is 12. Since it's area, I'm going to label it units squared. That's all for now. Thanks for watching.